Hello, and welcome to a fresh episode of AI 90. I'm your host Pulkit, and today we will be discussing the learning rate in machine learning. Previously, we discussed gradient descent, a technique used to minimize errors. You're listening to this podcast thanks to some gradient descent happening behind the scenes. It's like finding the best trekking way on a hill, but instead of treks, you're dealing with a mathematical landscape full of equations and parameters. Let's recap. A simple linear regression model looks like this: y equals wx plus b. Here, w and b are called parameters, x is called the input, y is called the output label, xy is a training example. After we calculate the loss using a loss function, the next step is to minimize it. But here is the challenge: the landscape can have multiple low points. Some are shallow, these are called local minima. But what we are after is a global minimum, the absolute lowest point where the model performs best. When using gradient descent, two new factors come into play: the learning rate alpha, the gradient, or the partial derivative. The partial derivative terms show the direction of moving towards the local minima. For instance, if it is positive, it reduces the value of w and we are moving toward the minimum. The learning rate alpha determines the size of each step. If the learning rate alpha is too small, there will be many steps and the gradient descent will become slow. If it is too large, gradient descent may overshoot. The derivative terms become smaller as we reach the local minimum due to a low value of slope, and steps become smaller. Thus, we can safely reach the local minimum without changing alpha. And that's how the learning rate keeps gradient descent in check. Keep listening and keep exploring AI with me. Until next time, goodbye.